So this is question number 45. ln of 5x minus 1 is equal to 3, and we want to solve for x here. So let's just write this, in terms of the logarithm here. So obviously this is a natural log here that we're looking at, right? It's ln. So here we have log base e of 5x minus 1 is equal to 3. Well, this is your base, this is your exponent, so e to the power of 3 must equal 5x minus 1, right? And so you can evaluate this, and really you just want to plug this in your calculator. So your x value is equal to e to the power of 3 plus 1 all divided by 5. Just plugging this value into your calculator, and for x rounded to 3 decimal places, you should get x is equal to 4.217. So that's the value of x here. It's just relatively simple. So for question number 46, I have something to do more with expanding logarithms, right? And really condensing them or expanding them. So we have those properties that are gonna apply here, right? So for question number 46, I have log base 2 of x plus 3 plus log base 2 of x minus 1 is equal to log base 2 of 12. And we want to solve this, right? And so if you recall, when you're really, putting these values together, right? The rule really states that log base 2, right? And then you have x plus 3 times x minus 1. And so again, when you're really condensing this, we're condensing this this expression over here, right? Log base 2 of x plus 3 plus log base 2 of x minus 1. The fact that they have that same have the same base over here, right? They have log base 2. You can put that here, and then what happens is you actually multiply x plus 3 times x minus 1. So you can really write this as log base 2 of x plus 3 plus log base 2 of x minus 1, right? Similarly, if you have something like, if you have something like log base 2 of x plus 3 divided by x minus 1, you can write this as log base 2 of x plus 3 minus log base 2 of x minus 1. Again, this is not to be confused with log base 2 of x plus 3 divided by log base 2 of x minus 1. Now, for this one, you just want to evaluate this in your calculator, right? But when you have log base 2 of this entire expression, then you can write this as log base 2 of x plus 3 minus log base 2 of x minus 1, right? However, for this one, you cannot write this as this, because these two values are completely different. So you can only write, this is a valid statement here, and this is valid as well. So those are just rules for condensing and expanding logarithms that you should be well aware of. So again, those are applied in pre-calc here. So this is what we have here, and we're setting this equal to log base 2 of 12, right? And so the fact that we have log base 2 here, well, if you think about it, really it's more like saying that, oh, log base 2 of a certain value is equal to log base 2 of a certain value. Well, in that case, it's much more like the transitive property, right? It states that x plus 3 times x minus 1 must equal 12, right? Because log base 2 and log base 2 are the same thing, right? So you're really saying that this must equal 12 then. Well, that's just a quadratic function. You have x squared minus x plus 3x, well, that's plus 2x. You have minus 3, but you're bringing the 12 in, so you have minus 15 is equal to 0. 5 and negative 3 have a product of negative 15 and a sum of 2, so you say that x plus 5 times x minus 3 is equal to 0. Therefore, x is equal to negative 5, comma 3, right? Now, when you do plug negative 5 in, right, although you're getting negative 5, in this case negative 5 is an Arrhenius solution, because if you do plug negative 5 in, it's always better to check your answer by plugging these values back into the equation. So if you do plug negative 5 back into the equation, you get something like log base 2 of negative 2. And clearly, 2 to the power of anything will never give you negative 2. Again, because no matter how large of a negative value you take in the exponent, it will just be close to 0. You will never get a negative value. So this does not really exist. So therefore -5 here, you just call this an erroneous solution over here. So it's erroneous, and obviously you know, it just doesn't exist. So when you talk about your solution set, you will say that x is equal to 3 is your answer here. So that's your answer to question number 46. X is equal to 3. So thanks for watching.